All right, what's going on, everybody? This video, it's going to be kind of long. We are going to go over how to calculate the student's t-distribution in Excel. Now, it's not as straightforward as you might think. There is a formula or a function in Excel called T.DIST. And in order to get the values from the student's t-distribution, that's not the only function that you will need to use to do all of this. So we're going to go over all three of them. All right. Now, this video is going to assume that you know how to find the test statistic. All right. That you know how to find the t-value. And then what we're going to use Excel for is to look it up. Instead of going to the table to look it up, we're going to use Excel to get the value. Okay. So what we're assuming that you know how to do is, let's see, let me get a pen here. All right. So remember, for the student's t-distribution, you can have a left-tailed test, you can have a right-tailed test, okay, and you can have a, I know these aren't the best drawings, but you can have a two-tailed test. All right. Now, I'm going to assume that you understand how to get the t-value. So remember, that is x bar minus mu over s divided by the square root of n. Okay, and that's going to give you some value there. And this is the value that you look up in the table to get your p-value when you're doing hypothesis testing. All right. So what we're going to do is this value here is going to already be given to us, and I'm just going to show you how to calculate it in Excel. All right. So basically, once we get this value right here, instead of going to the table, we're going to use Excel. All right. So let's suppose that you have a problem, and let me go ahead and write the problem down. So let's say that you have your null hypothesis is mu equals 9.2. Your alternate hypothesis is mu is less than 9.2. All right. And you calculate your t-value to be negative 3.267. All right, that's the t-value. That's the value you get when you plug it into that formula that I had written over in this box here that I erased. All right, let's say that's the t-value you get. So we know this is a left-tailed test because our alternate hypothesis, we got this, mu is less than 9.2. That's our left-tailed test. All right, so let's go ahead and see what we get here. And I'm going to make this a little bit bigger. All right, let me kind of, all right, so the left-tailed test. So in order to calculate this, so remember what we're looking for there is your negative 3.267. This is a left-tailed test, so we're looking for that area right there. So to do that, we'll click in here. And let's see. All right, so we've got to hit equals, and then the function is T.DIST, and then let's see what it wants. It wants the x value. You can see right here the x value. So that's your negative 3.267, comma, our degrees of freedom. And I know I didn't give that in the problem, but let's see, the degrees of freedom is 24. Okay, that's given to you. Okay, if you're wondering where that came from, that's given to you in the problem. Remember, the point of this video is to show you how to look it up in Excel. All right, and then I want the cumulative distribution function. So I'm going to type in true, and then I hit enter, and there's my answer. That's that value you would find up at the top of your student's t-distribution chart. Okay. So, and this is it's a one-tailed test. Now, on the student's t-distribution tables, you're not going to find this number here, this negative 3.267. You're not going to find that number in the chart. If you remember when you're doing the hypothesis testing, you're looking for something close, and you're going to say, well, the p-value is between this value and this value, if you remember that. But in Excel, you're gonna find the exact answer. Okay, you're gonna find that exact probability. All right, or that exact p-value. All right, so that's a left-tailed test. Now, let's suppose that we have this problem. All right. And I'm going to do a little more explaining when we get to these other options here. So let's suppose that we have, let me see if I can find some information on a right-tailed test. Okay, so let's suppose you're given a right-tailed test. It gives you the null hypothesis is mu equals 2.6. The alternate hypothesis is mu is greater than 2.6. And when we calculate the test statistic, the t-value, we get 2.940. All right, that's t. So basically what we have here is, here's your 2.940, and we're looking for this area right here. All right. Now, let's look at using this formula. So let's type in equals 2.dist, and our x value is 2.94. The degrees of freedom is, let me find the degrees of freedom for this particular problem, is 60. And cumulative, we put true. And let's see what this gives us. That gives us 0.997672. All right. So what Excel does with that formula, that T.DIST formula, is whenever you type in this x value, it gives you the area to the left. Okay, that's not what we want. We want this area here to the right. So Excel has another function. It's called T.DIST.RT. It returns the right-tailed student's t-distribution. So see, in Excel, it's important to know, is it a left tail, a right tail, or a two-tail? And we're going to do a two-tail after this one. But I want you to see what happens if you just go and use that T.DIST. That's not the right function to use for this problem because it's a right-tailed test. So this right here is wrong. So what we would have to do is equals T.DIST.RT. That's the right-tailed test. And then it wants X 2.940, and then it wants the degrees of freedom, which in this case is 60. And look, you don't have to type in if it's cumulative or not. It's just going to give you the area to the right of that number. All right. And so if we close the parentheses, we hit enter, and you can see we get 0.002328. All right. So let's do this one more time. And I want to show you something. Equals T.DIST, and I know I said earlier that's the wrong formula to use, but I want to show you something here. So I got 2.940 comma 60 for the degrees of freedom, comma true because I want the cumulative, I want the area to the left, and I hit enter, and you see what that gives me. Okay, now watch this. Remember, the area underneath the entire curve is 1. So what if I take this value this formula gives me, I click up here and I do 1 minus that? I wonder what it's going to give me. Look at there. You see that? So that's another option. Okay, that's another option. But, you know, I mean, you might as well use the .RT for the right tail. Okay, so just remember the .DIST, that gives you the area to the left. That's going to be used for a left tail test. Using the .DIST.RT, that's going to give you the area to the right. That's for a right tail test. All right. Now, okay, so your question is, well, what if it's a two-tail test? All right. And we know this is a right tail test because we've got mu is greater than 2.6. All right. So, you know, if you're watching this video, you've gone over hypothesis testing, and that's just something you're going to have to understand in order to use these functions in Excel. You're going to have to know, is it a left tail, right tail, or two-tail test? All right. So let's look at the last example. Let's look at a two-tail test. So I've got the null hypothesis is mu is equal to 9.5. I've got the alternate hypothesis is mu is not equal to 9.5. And my t-value, when I plug it into the formula, I get 1.250. And the degrees of freedom for this problem is actually the degrees of freedom. I'll go ahead and write it down. That's 24. Okay. And so this, there's negative 1.250. There's 1.250. And I'm looking for these areas right here. Okay. So I want a two-tailed test. All right. So there's a formula for it. I'm going to put equals T.DIST. Whoop, I didn't hit the dot. .DIST dot 2T. There's your formula. That's a two-tail. X is 1.25. comma, degrees of freedom is 24, and hit enter. Whoop. Too many. Oh, you see what I did? 1.25, I hit the comma. And so I hit enter, and there's your answer. That's for the two-tail. All right. Now, let's just try something here. Okay. So it's going to give us a better understanding of what's going on here. So remember, this right here is the two-tailed answer. All right. So let's do this again. Let's use equal T.DIST. All right. And let's put in negative 1.250, degrees of freedom 24, and I want true for cumulative. All right. So let's see what I did. So what I did, the negative 0.25 over here, okay, you see in the drawing, the negative 1.25 in the drawing. Remember, what I've plugged in, that's giving me this area to the left of that. All right. And so if I hit enter, this right here is this area right over here. I don't know if it's showing, I don't know if it's going to show up on the screen recording or not, but here, it's that area right there. Okay. Now watch this. Let's come over here. Let's come over here and do 2 times that. Okay. So basically what I'm doing is doubling that area. Watch this. Look at that. You see? All right. So you can use that formula for a two-tailed test, or you can use the T.DIST and use the negative value, and that'll give you that area to the left, and then just double it. And also at the same time, watch this. I can find this area right here using the positive 1.25. Now, what would I have to do to find that area? That would be the T.DIST.RT, because I need the area to the right of that number. All right, so watch this. Let's see what happens there. So I got equals T.DIST. What happened? T.DIST.RT. And then I've got 1.250, comma, degrees of freedom 24. And then what happens when I hit enter? That gives me that value right here. That's the area to the right of 1.25. And then at the same time, I can do 2 times that. I can double it, and there you go. So to use Excel, you really, really need to understand what you're doing, okay? So don't just think, oh, well, I'll just use Excel. Well, you can see there's so many options on how you can calculate these things, okay? But I just wanted to show you those alternate methods also, so you could, so you can see what's going on. I think it helps you understand it better. But look, if you're doing a left-tailed test, okay, so just to sum it up, if it's a left-tailed test, all right, I would use T.DIST. All right, so for a right-tailed test, let me move this out some. For a right-tailed test, I would use T.DIST.RT. And then for a two-tailed, I would use T.DIST.2T. Those are your formulas. And that's all the formulas you need in order to do this. That's the 3 that you need. And then I went ahead and I showed you all the other ways that you could do it by, you know, manipulating some of these other formulas. Okay. All right. So I hope this helped. I know it was kind of a long video, but hopefully you understand it now, and hopefully it helps you understand your other stuff, you know, doing it by hand. Hopefully it helps you understand that better. Okay. So thanks for watching. Give me a like, share, and subscribe. Check out my other videos, and I will see y'all later.